Alright, before we go into the perspective itself, I just wanted to kind of look at the desktop launcher a little bit again. Remind you that it's fun to go ahead and experiment a bit with the window size. I was trying out full screen. It's as simple as this. Full screen equals true. Then just set it to some resolution that will work on your screen. For HD, obviously, the native resolution would be this. And that works. In some cases you'll get a warning from Windows about not using the optimal resolution, and if you use a resolution that doesn't work on the screen, you simply get an error. But in order for this recording to work nicely, we'll just go back to some nice setup of the screen here. Something like this. I have a split screen setup that we'll look at in a moment. Rendering. Let's just see what this looks like. Yeah. So our split screen setup, and I'm going to be rendering what my camera that I'm moving around sees, for one, and on the other side I'm rendering a top-down view, and we're going to look at how we make this and a few more things. So to begin with, we have functions already here in the game class, that you got in the base project. We had this orthographic projection here. I'm just going to let you know right off the bat, you can take the bottom part of this code and you can simply erase that. So that was setting up, it was affecting the view matrix as well when you set up the orthographic projection, which is fine when we're using it for the 2D projection to make sure that the view matrix isn't mixing things up. But for now, we just want the projection to be projection and the view to be view. So we've already made this camera class here, and in this camera class we're setting up here in set shader matrix. We already have this code here. So this stuff here is new, but this is what we should already have here at this point. Setting up the view matrix, so we're using the view matrix pointer. So in the camera class, I've added the projection matrix pointer as well. So we have view matrix pointer and projection matrix pointer. The constructor takes both of them in. And another thing I'm doing here, I made a new set of variables here. Left, right, bottom, top, near and far. And I just set all of them to, well, -1 and 1. So that's basically we'll make a base projection matrix for more or less no projection, just projecting straight into clip coordinates. Okay, so back to the game. What you can do is you can simply copy these functions here, the perspective projection and the orthographic projection. And you can take the code that's inside them, that is where we're building the matrix, and let's go back into the camera class and put it into set shader matrix, or set shader matrices we could actually call it now. So if I rename this set shader matrices, okay, otherwise no difference. Okay, so what I have here as well is a Boolean switch called orthographic, just telling me, am I using an orthographic projection or am I using a perspective projection? And in here I basically say, if it's orthographic I do one thing, otherwise I do another. And the code from orthographic projection here, I put inside if orthographic. This code here from perspective projection, I put into the else, and then both of them share this, basically setting the matrix itself into the actual shader matrix. Okay, so just to make sure that everyone can see this code. You can look at it here all the way. And you can just pause it wherever if you want to write it up. So the idea here is that the code we had in here, which I'm now simply gonna remove, this orthographic projection here we can remove from the game class. Let's see if I'm accidentally calling it somewhere. Okay, I'm building my camera and everything here, so this is unnecessary. Okay, so we removed that, and what we have in the other function in the perspective projection function is we simply have hard-coded numbers here for a certain projection. So we have some numbers here and here, here, and then the -1 here. It's basically a hard-coded for specific numbers, basically a 90-degree field of view. And I think a camera that has a near plane at 1, a far plane at 100, and a field of view of 90. It's basically the hard-coded camera here, so we can throw that out as well. And inside the camera class we have to make sure now that we take these hard-coded numbers and instead we say this is 2 times near divided by left minus right, right minus left, sorry. So that's the top corner, and then down on the diagonal line we have 2 times near divided by top minus bottom. Up here for the translation, you can look at this matrix in the slides as well. It's all explained there, and what these numbers are and why they're here. Right plus left divided by right minus left, same for top and bottom. And finally we have these values here that set the pseudo depth correctly. So minus far plus near divided by, okay, so this is still in the diagonal line here, and then this is in the final here. So the last column is 0, 0, then this number, then 0. The next to last column is this number, this number, this number, and -1. And the first 2 columns are this 0, 0, 0, and 0, this 0, 0. So just go through this. You can write this up from me, or you can write it up from the slides. Either way, we have this matrix array here. For the projection, we either set up an orthographic projection or we set up a perspective projection, depending on what we have here. And then we simply put this array into the matrix buffer and send that into the shader. Below here, we then do the same as we did before, set the view matrix in the same way. So we're setting 2 matrices in here. And then I built 2 other functions here. One to set an orthographic projection, and it takes left, right, bottom, top, near, far, and it simply sets all of these, sets orthographic to true, and that's all it does. That means that the next time this is called, we go in here and use these left, right, bottom, top, near, far values. The other one is the perspective projection. Now it takes these variables here, the field of view, which is the angle of the camera. It takes a ratio, which is basically the aspect ratio of the screen that we're going to send it up onto, or whatever aspect ratio we want on it. It doesn't have to be the same as the screen, but we'll get skewing and stretching if it isn't. Near and far. And then we set top, bottom, right, left, near and far on our in our class here to these values again. We set orthographic to false. So the values here are top equals near times the tangent of half the field of view angle, and then we're changing it into radians as well. So we're doing a radian change here, we're dividing it by 2, but it's basically half. This should be like so. So it's the tangent of field of view halved times near, times n, times the the near plane distance. And bottom is simply minus top, so it's a symmetrical perspective projection here. Right equals simply the ratio times top, and left is minus right, and then near is near and far is far. Orthographic is false, and these are the only functions we need here to set up these projections. So we store these values, left, right, bottom, top, near, far, as part of the class. When we set a new projection, we simply set these values, but we don't actually make the matrix yet. But when we call set shader matrices for the camera, we set both the projection and the view. So the camera class in its entirety, if we just scroll slowly through that, we have the constructor there setting default values. We have look, which we've already built earlier, setting up this coordinate frame of the camera, and actually not making a matrix, just setting up the coordinate frame, and the coordinate frame is used to make the matrix when we call set shader matrices. So then we have these helper functions here, set I, we have slide and roll, we have yaw and pitch, and we have orthographic projection and perspective projection, setting these values. So still always just editing. These are just affecting the coordinate frame. These are affecting the projection variables, and in set shader matrices we do all of this. And it's important to understand that we use all these functions here, set up the orthographic projection or the perspective. We change the camera, set up the entire thing either in create or in the update functions, doing that all around. In some cases inside the display function if we're using other data to set it up. But either way, it's not until we're going to actually display using this camera that we call set shader matrices. We have nothing to do with the matrices inside the shader until then. And this we should do in the display function, because in the examples that we're going to look at now, we actually have two cameras, and we're setting up the shader matrices for each one before we draw whatever we're going to draw inside that camera. And so we want to be able to call set shader, basically keep track of what the cameras are doing without that changing between frames, except changing incrementally. And then when we actually display, we're just gonna take the build from whichever camera we're gonna use, set that into the matrices, draw, then take the other camera and set that build into the matrices and draw. So if we have a split screen game with two cameras which are independently controlled, we can have an instance of the camera class for each one, and then when we draw we simply set the shader matrices for one and draw that, set the shader matrices for the other and draw that. So let's look at how we're setting up this camera here. To begin with, here I have what I call camera and what I call overcam. So in this case it's the overcam. We could actually just now do a different thing and say I'm gonna rename this overcam just to cam2, or actually let's call it orthocam, like so. So okay, I have camera, cam, and I have orthocam. I'm going to go here, I'm inside the create function, and here I'm building this camera. So cam is a new camera, and I send it these positions, these pointers to where the matrices are in the shader. And I send the exact same pointers into the other camera. So they'll be affecting the same parts of the shader, it just won't be affecting it at the same time. So now I call look for this one, and I just set up some nice position and orientation that works for me. And the other one, okay, what we should do here as well, I remembered suddenly I'm doing that now in the display function somewhere here. We should make sure that we're setting, I'm going to take this out here. So we're not doing it inside the display function, we're just going to be doing it here. Okay, so I have a perspective projection here, which I'm going to set just to 90. I'm going to say I have a 90-degree field of view. I have an aspect ratio of 1, so it's a square screen. And then I have a fairly short near plane and a ridiculously long far plane here. This was just an experimentation. So let's set it back to something like that. Okay, so a 90-degree field of view here. We have a near plane that's fairly close, but not too ridiculously close because we don't want to lose the pseudo depth values or the detail in the pseudo depth values. And then we have 100 as the far plane. So here I have an orthographic projection. I'm just going to set the near plane to the same. I'm going to set the far plane to 100. And then we simply just have to kind of decide how wide we're going to have this. Let's stick to -5 to 5. So this is left, right, bottom, top, near and far. Okay, so now we have the orthocam, we have this cam, and I'm going to call the same look function for orthocam. I'm actually going to do one thing here, which should not take too long. I'm just simply going to double all of these things. Yeah, I know it's a lot of double code here, but just to test, and we'll take this out. So just to test this, wait, no, this is unnecessary to double. Then I'm going to take orthocam and we'll just, so we're doing the exact same things for cam and for orthocam. So since we set them up with the same look, we set them up with the same look, and we do all the same motions in the update functions. And then when you come in here, I'm simply going to say when, so I'm going to take this out as well. I'm just going to do 2 lines in each. One of them is just setting the viewport, and then cam set shader matrices. So I basically put a for loop that goes through all of my display code 2 times. And it just does the exact same thing every time, except I have this little if function here. If it's viewing for the first time, I set up this viewport and I call cam set shader matrices. If I'm viewing for the second time, I set up a different viewport here, same size, just starting with left in a different spot in the center, and then I call set shader matrices for orthocam instead of cam. Let's see what this looks like right now. Okay, so we have 2 screens here. Okay, one thing I'm gonna take out here. This code, we can put that back in later. It's just getting in the way now. So we have 2 views here, both viewing from the exact same spot and viewing the same things. For instance, now I'm gonna find a nice spot here above this, not get any clipping and stuff. I'm gonna move back and forth. So I'm moving closer and I'm moving further away, and you can see that on the orthographic projection here, this motion simply doesn't happen, or it doesn't look like it's happening. But when I start near plane clipping, you can see that I'm actually going through the pyramid. But the thing is, it's projecting parallel to the z-axis and the i-coordinates rather than projecting towards the camera. So it's just always projecting a box, an actual box with 90-degree corners. So looking around makes a difference, but it doesn't actually have any perspective. It doesn't have any distance perspective. So we don't feel that we're going further or closer at all. And we can see that the pyramids, if we go fairly close to them here and look at both of them, we get no sense of one being further away than the other. They just look the same height, the same size in the orthographic projection, whereas in the perspective projection here, you can definitely see that one of them is further away, the other one is closer. The only thing that makes the back one, the rear one, further away is that it ends up behind the other one. Okay, so just to get a feel of the difference between an orthographic projection and a perspective projection. So what we did then, I'm just gonna do a few things here. Like so. Okay, so now we're probably setting this up the same. Okay, now, so we have the top-down view now. Alright, so let's look at what we're doing now. Now I'm going to change the orthocam a bit. So I'm going to set it to a bigger view here, and you can just experiment with this if you want. I don't really need to have the near plane. It's near, I think, so I can just do something like this. And I am not going to call look for this here. And another thing I did is that I made this field of view variable here, and I'm actually gonna skip this here. It doesn't matter, we can set it anyway, but might as well not, since we're gonna be updating it inside the display function as well. So I'm using this field of view, and then I have a little code here that actually changes the field of view. It's not very sophisticated, but it's a way to kind of get a little bit of a feel for how you can zoom in and out. Okay, so I'm setting the perspective projection here. Here, however, I can do one of two things. So the overcam actually doesn't have any position yet either. It has the orthographic projection. The other one has the beginning look, so we have a beginning position for that. What we're then going to do is that when we're drawing the first time around, we're going to set the perspective projection here using this field of view, which might change between frames. And then we set the shader matrices for cam. In the other case, the idea here for overcam was to say, I'm going to call, oops, it's orthocam now. I'm going to call look every single frame, and what I'm going to use as the camera's position has the same x and z coordinates as the camera's eye, and then the y coordinate is 20, so it's always 20 above. And what it's looking at is the cam eye, so it's looking straight down. And then we have the up vector. We have to make sure it's not 0, 1, 0 anymore, because that would be parallel to the direction we're looking in, since we're looking straight down. So 0, 0, minus 1 is what I set up here. You can experiment with that as well. So then I set the shader matrices. So I'm setting a new look for the orthocam every single frame. Let's see what this looks like now. Okay, and another thing I did here at the bottom is I said if this is the second time we're drawing, I set a new color and I do a translation and I draw a cube, and the translation is to the camera, meaning that this red dot here should be drawn exactly where we are. So here we're seeing the entire scene from the point of view of the camera. Here we're seeing the scene from a top, always standing exactly above ourselves, and the red box is drawn where the camera is in the scene. So like so, and it's following us around. Okay, since we're following us around, we might as well make this whole thing a little bit smaller here. So just by setting new values for left, right, bottom, and top, we have a smaller map smaller portion of the map, and we're following it around. And you can actually see that we're drawing the same 3D scene. If I go above the pyramid, you can see that the red dot is on the top of it. If I dive into it, you can see that I go inside. So it's actually a three-dimensional scene I'm drawing here, but I'm drawing it with an orthographic projection, so we don't see any of the depth in that. You can experiment with that by kind of setting the camera off to a side and not having it exactly straight above it. And the other thing we can do here, we can go back to this big view, and then we can go in here and say, I'm going to change this look from using the camera to just being a fixed point somewhere in my scene. And then instead of having a map view that's following me around and I'm always the center of it, it's a fixed map and I'm moving around in it. So you can still see the red dot there. Now moving around on top of the pyramid, and now diving into the pyramid. So have fun with this experiment. And again, we can end up looking a little bit at more code here. So I'm just going to look at the display function in its entirety. You can pause wherever you want to see exactly what's going on here. So the idea here, a for loop around the entire thing, going through it twice, and then just some of the things are done only the first time or only the second time. The rest is just done always, like load identity matrix, pushes and pops, building the pyramids. Now I'm doing two pyramids, so I put a for loop around here. Obviously, it'd be a better idea to just take the pyramid code and make it and put it into a function, and then say just call draw pyramid twice rather than having this for loop here. It's completely unnecessary, but no, you can do that instead. Just take this entire code, put it into a function, and then maybe call it with the color as variables. So I'm saying if pyramid is 0, I use this color and translate this amount. Otherwise, I use this color and translate this amount. But you could so easily just make a draw pyramid function that does all that code and takes the color as a variable and the translation as a variable, or the position of the pyramid. Anyway, so we have this pyramid code here, and we can see that here is where I'm scaling to make the walls flat. So I'm setting them to 0.2 on the x-axis, but 1 on y and z, or I'm setting them to 0.2 on the z-axis and 1 on x and y, and I'm just using a modulus here. So whenever I is an odd number, I do 1. Whenever it's an even number, I do the other. So it's just experimentation, just throw things around and have fun with it. And finally I draw the cube, the red cube here. That's the display function. Render still just input update display. All of this I'm not using, but you can definitely use these callback functions instead of the if sentences here that I'm using to get the keys. And we have these keys here. And this is the main part that we've been changing in the create function. Everything that's above this is code that you have given. We're going to start changing that code very soon when we go into the shaders, but for now this is just stuff you don't worry about. We added some things here. You can see that we added these cameras and the field of view. And so the part of the create function that we're interested in is just this part. Okay, and for the camera class again, I already rolled through that, but this is basically it. And that's all we're using. The rest of the classes are just unchanged from what we've been using before. And just one thing I want to do here in the end is just to kind of look at what happens when we change the field of view. So to begin with, let's just try setting it up here. Let's skip the field of view variable there. Just say we're going to set a field of view of, we already used 90 degrees. Let's try a tighter angle so that it feels a bit like we're going slower, but it's more like tunnel vision. looking around here. Whereas if we go wider instead and say let's do 110 degrees, see, we get something that's a lot more skewed on the sides, kind of. We're seeing a lot more around us. And you can experiment with these numbers, but we can also just go to the extremes by actually having these. So now I start at 90 degrees. Now I'm going to stop moving and I'm just going to zoom. So now I'm just zooming in. So now I'm walking around the camera on this extreme zoom. Makes it a bit weird to move. And I'm going to zoom back out to something really wide. And when we start moving, the feeling is entirely different. Now this is ridiculously wide actually. And I'm not stopping this at numbers that don't work, so I believe that if I just go all the way back, I'll just kind of go into a circle. And everything is suddenly upside down because it just went to the other side of the possibilities for angles. So I'm just getting the negative sine or cosine by just going into basically negative angles. So that's okay. And if I zoom all the way in, I'm not sure what happens actually. Yeah, same thing. You just go past zero and into negative angles. So if you actually want to have a zoom feature, you should cap that on something, and maybe not always have the motion necessarily linear, but just something that feels right. Maybe always some kind of proportion of the distance between 0 and 180 degrees or something like that. So you never actually hit 0 or 180 and you go slower as you get closer to either end. You can try that out if you want to have a zoom. So that's the field of view. You can also go ahead and try to change the ratio without actually changing the ratio of the screen. So now I'm telling it that I have a screen that's too wide. So suddenly my pyramids are super tall here. I'm going to zoom a bit. So I'm simply taking something that I'm imagining when I draw it or when I render it, that the screen is twice as wide as it's tall, but then I'm putting it on a screen that's equally wide and tall, and then you get this. So if we take this to the extremes as well and say something like this, and also it'll start feeling like the camera is much wider because the field of view is the angle up and down. The other angle will be affected by the ratio as well. One more thing that's interesting to look at here is also, yeah, okay, this isn't what I wanted to have here. Really did want to have is, for instance, z-buffer fighting. If we take the far plane a bit far away and then put the near plane really, really close, look at that. Look, on the yellow pyramid we already have z-buffer fighting. What's happening is basically we're making the near plane and far plane so wide apart, and the near plane so close especially, that the pseudo depth values that we have for depth testing, the detail is simply enough or not enough, or we're wasting all the detail close to the camera where we're not really needing it. And so further away, the front sides of these walls and the back sides of these walls are actually ending up with the same values for depth. So OpenGL can't decide which one should be drawn and which one should be skipped, or which fragment should be dropped and which fragment should be drawn. So up close it's okay, but the further we go away, the more z-buffer fighting we get. These are glitches that we don't really want to have in our program. So put the near plane as close or as far away from the camera as you can allow yourself without starting to near plane clip. Put the far plane as close as you can. And you can try to take a near plane and put it further away. And we just start near plane clipping too close. We start clipping off of the pyramid too soon. So look out for that near plane. Don't have it too far away. And if you start getting this, you can always move the near plane. But also don't just go and say, I'm just going to put the near plane super close to make sure that nothing clips. Okay. Now everything is actually just ridiculous. Let's put the far plane further away. We're not far plane clipping. No, we're not far plane clipping. We're Z buffer fighting. So everything is getting more or less the same depth values here. This is super weird. So you can't just put the near plane this close. You have to have some value here, but just set it so that you don't near plane clip, but not too close. So this is nice. So we've looked at near plane clipping, we've looked at the field of view a bit. You can look at the far plane as well. If I put that just a 10 away, now we're far plane clipping the entire yellow. You can see now they disappear into the distance a bit too soon. In some cases we might want to far plane clip, but then we can have things like fog to make that a little bit smoother, so it doesn't just suddenly clip at a distance. So far plane clipping, near plane clipping we've looked at. Experiment with all of these values. Just do what you think is fun. Have a little fun with this, but understand that, you know, somewhere between 60 and 90 degrees is nice for the field of view, but then experiment with that. Go ahead, don't take my word for it, experiment with it. The ratio should be the screen ratio that you're going to set it up on. Near plane, not too close, but not too far away. Not too close because you don't want to waste pseudo depth values. Not too far away because you don't want a near plane clip. The far plane isn't as exact because we're wasting less values further away than we are up close because of the way the pseudo depth function works. And experiment with the orthographic and perspective projections.